So today we want to learn a little bit about using trigonometry to solve for sides of a vector, or sides of a triangle, and components of a vector. So we've mentioned already that every vector, in this case this is vector D, has a horizontal component and a vertical component. We are going to use that then to help us solve when we have an angle and the vector, what those actual components would be. So we need to do this so that you're in the lab and you're trying to get projectile motion and all these types of stuff. We need to be able to solve for these sides so that we know what's going on. All right, so one of the mnemonic devices that's always been used for trig functions is SOHCAHTOA. And in this case, we're going to focus on the SO and the CA because we are going to try to identify the sides. We do not have the sides, and we're trying to identify the vector. If that was the case, then, or the angle, we would be using TOA. But in this case, we have the vector and the angle. We need to know what is its y and x dimensions. So for this problem, our vector is going to be 190 meters. The angle is going to be 26 degrees. And we're going to use these functions down here to help us solve for the horizontal component and the vertical component. So when we're looking at this, first let's start. A is actually solving for the horizontal component. So we're going to start right here. You're going to take the cosine of this angle. So in this case, it's 26. And then you're going to take the adjacent. Let me kind of give you a little bit of help on triangles and some remembrance on triangles. This guy will be the hypotenuse, and this guy will always be the adjacent. So whenever you're trying to identify that one, that'll be the process. This is always going to be the opposite, and the vertical component will always be the opposite of a vector, and the horizontal component will always be the adjacent for our purposes. So that being said, we're going to take this cosine theta, and we are going to use this formula here because you can see I want to solve for the vector in the x direction, and then that means we're going to use this equation. So we come up over here, we say we want to use cosine of 26 is equal to, and we want to know what this guy is, and we have 190 meters. Okay? So this is pretty straightforward here. We are going to be trying to solve for that variable, so we have to multiply both sides by 190. So we should get the cosine of 26 degrees times 190 is equal to dx. This guy here is going to be the sine of 26 theta is equal to d in the y, 190 on the bottom, multiply both sides by 190. So we end up getting that guy is equal to the sine of 26 degrees times 190 meters. So that's how you're going to find the horizontal component of each one of those. If you look real quick, you could rearrange these guys. If we were solving for the y component, you could just go ahead and write down that it's going to be the sine of the angle and times the vector, and d sub x would be the cosine of the angle times the vector. So that's really going to be how we are going to look at this problem. You do not have to start from this guy. You literally can just identify which one you should be going for. So if you're looking for the vertical, it's always going to be sine theta times the vector. If you're looking for the horizontal, it's always going to be cosine theta times the vector. And that'll help you identify those distances whenever you are given the actual vector and the degrees at which it, from east, at which it was sent out or traveled. Hopefully that makes sense. We're going to be doing practice problems in class, so hopefully you took notes over this, and let's get started. We are looking for the V, the horizontal and Y components of the V vector. We are given this vector. So you see that V is equal to 90 meters, and we'll have to make sure we say per second, because we're doing a velocity vector here. It is sent off at 30 degrees, so we know that our theta is 30 degrees, and we need to solve for A and our problems are A and B, so we're going to solve for the horizontal velocity and the vertical velocity in these components. We are going to use our functions that we left up here, and so we're going to go ahead and use these two down here. Rather than go through the whole process, plug in the data, we're going to select the equation that we need and then plug in from there, rather than plug in and do the algebra. So if you identify here the velocity in the horizontal direction, that's what V sub x means. We are going to find the velocity in the horizontal, so we're going to use cosine times the theta, and we need to change these to V's. Okay, so times the original velocity, or the velocity of the vector. So we're going to use this guy right here. So we should have, this guy's going to be equal to the cosine 30 times 90 meters per second. Let's just go ahead and do it like that. Then this guy here, we're going to be using sine. So we would say it'd be sine times 30, 90 meters per second. And I believe when you put these in your calculator, it will get, you will see this instead of parentheses on the outside of cosine. That's what you're going to end up getting for those. I'm going to go ahead and let you guys finish that off. Please make sure you get an answer for that, and then we are going to move on to the next practice problem. Okay, so I added to our equations down to the bottom the TOA. I wanted you to see these guys because these are some functions that you're going to be seeing when we start talking about projectiles and motion in two direct dimensions as we're talking about vectors. I showed you this guy last week in your homework problems. We need to move on and really understand these concepts and not be scared of them and why this is happening. So basically this is just set up to show you all the different things that you could solve for. Really it is each one of these identities and then being able to use those to solve for whatever you need and identifying what it is that you need. So we're going to start off with a problem. We're just going to first, we want to know the angle. So we're going to say that the velocity in the y direction or the vertical direction is going to be 10 meters per second. The velocity in the horizontal direction we're going to say is 2 or 5 meters per second. And then we're going to say we want to solve for the actual vector or your velocity, and we also want to solve for theta. What was this angle that we went out? So using this information, the first one I'm going to identify to solve for theta is this guy there. And then once we find theta, we will move into solving for your horizontal. Or sorry, your actual velocity, not your horizontal. So first thing we'll do is go in and establish that we need this equation because we're solving for theta. And we're going to say that it's going to be our y, 10 meters per second, divided by our x, or horizontal. Okay? So then we're going to solve that out. We should see tangent, inverse tangent of 2. Okay? To get our answer there. That'll give us our theta. To solve for your actual vector, we'll go ahead and use Pythagorean theorem. So we'll have 10 squared plus 5 squared is equal to c squared, or is equal to v squared. Kind of gets you the idea there to solve for this guy. So that'll be 125, so it's the square root of 125. We'll go ahead, we'll give you your velocity vector, because that's 100 and that's 25, so square root of 125. Go ahead, put those in your calculator and get those answers. And then once you get those answers, you'll plug them in there.